seen a lot of great presentations today. And what kept me thinking is that it's a little bit strange for us designers and architects to be in a scientific conference. But I keep thinking about Heidegger, who famously said that unlike the notion that you think we have science and then there's technique to prove it, sometimes there is technique that would then lead to scientific discovery and findings. So, and this has been our approach at Anonymous as a transdisciplinary design firm to explore this sort of narrow realm of techniques, and that has enabled us to work with great companies like NASA JPL and more recently Hyperloop Transportation Technologies. So I want to begin with this image by Pierre Paté in 1769 of what he called a street, not any particular street, not an existing street, but basically any street that he envisioned back then. And Paté thought, well, if we have circulation on the street of people and carriages and vehicles, how about we also produce a completely separate and autonomous system of circulation underground for circulation of water and sewage that can even connect to the buildings and basically tie it all together in a system. It took 100 years after this drawing for this to be realized. But we see the idea of something like a street that already existed, but beginning to be thought of as an urban infrastructure. And since we started working with Hyperloop Transportation Technologies, we thought of Hyperloop in a similar way, that we, instead of coming in a way to make it look pretty, our job is to rethink what Hyperloop is beyond just a mode of transportation and mobility. So beginning, we worked on a number of separate projects with HTT, and one of these was the task of rethinking and redesigning the pylons, assuming that the tubes are above ground. So early on, we thought of approaching the project, and we called it Hyper.structure, so that the idea is not that we think of pylons just the same way as the elevated highways of 1950s and 60s have been, and we know what happened to that. But we really think of it as a new urban infrastructure that could bring new forms of life. So we started researching, basically looking at different aspects that we were interested in, from circulation and mobility, which is the obvious one, to energy and sustainability. We looked at separate projects, how to even generate energy from pedestrians moving and walking. We looked at program and economy and how to activate spaces, green and urban spaces. How could these spaces, become more positive public spaces in cities? The idea of structure and infrastructure itself, of how that could function. We have case studies here in Portugal that a city was developed by building these elevated, infrastructure that carried pipes and electricity first before there were even any homes, and the homes were built by just plugging into it. So in a way, you can think about the pylons and the Hyperloop tubes in the same way, as a way for future urban developments. Also culture and community, and how these spaces could foster that. And then we started going through a very long design explorations, looking at implications of what does the pylons mean if they are elevated. If we have one single column in the middle, if we have two, if they're shifted, if they're aligned, if they're misaligned, if they're zigzagging, if there's two tubes, if there's four tubes, if there's pedestrian on top, if there's pedestrians below, and so on. So there's, this goes on forever, and I don't have time for it. But we finally honed into sort of these schemes that we thought works best, both structurally and would create better spaces. The key discovery, looking at pylons in general, whether it's Hyperloop or highways, is that when you have columns in the middle, much like the highway systems, you end up with leftover spaces on the sides and these sort of corridors that lead to nowhere. So, which is why they end up being dead spaces in cities. The moment you double them, you still have these, you know, sort of passageways, but at least you create a space below. So by shifting that, not only you maintain this corridor, but you also start to create spaces on either side, potentially using it for programs and activities. So this is basically two of the schemes that we developed. I'm going to just focus on this one, where you see the tubes here, pedestrian passageways there that would connect directly to buildings, and public spaces and programs under the ground. Again, the whole thing could be wrapped around the skin. That would then could be solar panels or green screens, and bringing all these different activities and functions together. Looking at how this could improve streets rather than being an obstacle added to a city. You know, there would be an incentive for planners to even integrate these tubes. And again, to now rethink Pate's drawing, I mean, we could actually start thinking about these zones as a new place for infrastructure. In this case, to play a devil's advocate, we're arguing for an above ground because it's more accessible, it's easier to maintain, and you can add and remove stuff, especially nowadays with telecommunication that upgrades almost every month. So, and here's an image of what those type of spaces could look like. We also looked at the interior of the capsule. In a way, it must be a claustrophobic experience to be inside a space that is so small and there's no windows. One approach is a more conventional approach that we're familiar with, you know, you can imagine almost any mode of transportation today, and integrating digital screens. Another is to actually take advantage of the fact that there is no windows, so we can produce a more immersive environment where you can actually, you know, be anywhere and experience with your family. And a more economic approach, which is a problem. I'm from New York. Most of my life lived there. And if you go on any city in a subway, you start to experience the problem that the seats are designed for a certain size, age, you know, and that some people like leaning, like me, on the door, even though it says don't lean. And also, when no one's sitting there, you have to stare at an empty seat, which is kind of sad and ugly. So we came up with this idea of using the circle to rotate the seat so you can adjust it to your height, you can lean on it, and if no one's there, it just rolls on the ceiling and you have a screen there for whatever, advertisement or entertainment. But most of our time we've been looking at the design of the stations. So if you consider the scale of the stations, they're pretty large. Based on our calculation, you come close to the size of the Pentagon, which is big because of the turning radius required. So for us, the stations were more than just a building. It was more like an urban design project. So we did two stations, basically two terminal stations. This one was in Al Ain, and a different view of this, and another one in Abu Dhabi. And we conceived the way the station works. There's really like no precedent for it, obviously. It's like being asked to design an airport before even there is an airplane. So for us, this was a great opportunity to really think, how would we like the travel experience to be? For us, it was about the idea of having a no-stop station. So you don't pause, especially nowadays with security and all this sort of waiting. We wanted the Hyperloop, if it is a high-speed transit, it's not going to work if we have to wait in line for like half an hour. So the way we conceive the station is that I'll just quickly explain to you in this. So you have a drop-off level on this level, and then you go through, depending on wherever you are dropped off, there are these sort of stores and duty-free, and you're filtered through here, and you're in this zone. On the floor, there are three really, based on your ticket, you're given zone A, B, or C. and you have signage that will guide you to one of these 3 ramps. Based on which zone you are, you get onto that ramp. It already brings you up to that zone, which is 1/3 of the circle, and by then you already see your gate. So for us, this was the quickest way, and this is just to give you an idea of the signage system that we wanted it to be intuitive, so you don't have to look for the sign. You can just look down, and the floor system already, the zigzag points zone A, zone B, so at any point you know where you are and what's the closest path to your pod. A view of the skin and the level below, which we thought it would be open to public with work, commercial, and other type of public activities. The skin is really a porous skin that it's, in fact, even though it looks weird, is not really designed, because all it is, it produces openings where the building is open to ramps or tubes. So, and then that produces the undulating surfaces. If you unwrap it, it's about 1 kilometer long. So that's another reason why it doesn't make sense for it to be an actual building skin, and it would be more porous. So, no? Okay, that was supposed to be a video. It didn't work. But anyway, you start to see here the car ramps and the tubes that start to penetrate through the skin to create openings. Here are different views. Because of that, obviously, from any angle, the skin looks different. To quickly show how it works, you basically, with your car or your Uber, go through this opening. This is the drop-off area, which is, the skin on the left. The actual building starts on the right, and you can be dropped off anywhere because doesn't matter the distance. Then you're inside the space, this space with a central atrium in the middle. That is in the middle, which you see a big park open space, and then you're through these ramps. You're led to the platform level where you will be entering your capsule. And here's a view at night. Okay, thank you. Questions? Yes. So the question is why the station needs to be so enormous. So the easy answer for me to say is we're given the parameters by the client, so we have to do it. But the correct answer is because these were terminals and the turning radius for the tubes needed to be a certain minimum. So this is the smallest we can get. This is how this approach is based on, which is the HTT uses as a dewdrop scheme. Yeah. Yes.
So are you suggesting when you said the elevated in Manhattan, they have a very successful park known as Pylon Park, which is an old transportation system that they turned into above ground park that's been extremely successful. Are you suggesting that maybe the Hyperloop in a city would have its right-of-ways would be park-like?
That's so. The question is if our vision of the pylons is similar to High Line in New York. That's certainly what. If there is going to be an above-ground system, that's certainly what we hope for. But in general, I think as an urbanist, I think one of the problems with density in cities is that we rely too much on one surface. Everything happens on the ground. If you look at cities like Minneapolis, or they're starting to explore levels, and that alleviates some of the pressure on one level. So with the pylons, we don't think of it as above ground. We in fact think of it as creating a new ground on that level and rethinking buildings and to having a new level of access. So Highline and projects like that certainly a good reference. Yes.
The drawing is, we tell you, it looks like a monument to the new technology, but the cost must be colossal. It looks like a sports stadium. So it must be $1 billion to create this. Has any kind of numbers been thrown at it?
Yes, not that I know of, but in reality, there is no additional cost or not much cost in it for the design and appearance of it. We're using what you see in, let's say, an image like this is a screen, which is very economical. In a lot of stadiums, like if you look at NASA Coliseum in the East Coast, and they're remodeling, or the new LA stadium, they use these type of skins because it's relatively cheap and it helps sort of wrap the building and give it an appearance, but it doesn't require actual, as you know, like concrete or steel structure in many cases. They're easy to set up. So the actual core and shell of the building is relatively simple construction. And it is large, so it is definitely expensive. But then you know, we're kind of focusing on, in a way, this is really what it is inside. We're really focusing on how to make it work within those parameters and make the experience more interesting. But yeah.
Thank you very much. We can continue the
Yeah.
questions
Thank you.
after the panel discussion. Thank you.